Welcome to The Explainer. Today, we're diving into one of the most important scientific papers ever written. It was delivered way back in 1888, and it laid out the blueprint for the engine that quite literally powers our entire modern world. So picture this. It's the late 1880s, and electricity is in the middle of a huge fight for the future. It was called the War of Currents. On one side, you had Thomas Edison's direct current, or DC. It was the standard, but it had a massive weakness. It couldn't travel very far. Then you had the Challenger, alternating current, or AC, which could be sent for hundreds of miles. The only problem, and it was a big one, was that nobody had built a good, reliable motor that can actually run on it. And this is where Nikola Tesla enters the scene. But what's so brilliant is that he didn't just try to solve the AC motor problem head-on. First, he took a step back and realized the system everyone was already using, the DC system, had a clunky, inefficient secret of its own. He started with a really basic fact of physics, something everyone knew but nobody really thought about. As he pointed out in his paper, deep down, every single generator naturally produces AC power. Yep, even the ones in Edison's DC system were making AC on the inside first. So if generators make AC, how do you get DC? Well, you use a clunky mechanical switch called a commutator. And Tesla, he despised it. He saw this part, with its sparking brushes and constant need for repair, as the single biggest weakness in the whole setup. For him, it was the source of almost every failure. Okay, let's just walk through how inefficient this was. You start with a generator making perfectly good AC. Then a commutator chops it up into DC. That DC goes down the wires to a motor, where a second commutator has to turn it back into a shifting magnetic field to make the thing spin. Tesla saw this and thought it was just absurd. You're converting the power twice for no good reason. And that insight changed everything. He realized the real problem wasn't just how to build an AC motor. The real goal was to get rid of the commutator completely. This led him to the question that would change the world. How do you make something spin using AC directly with no messy mechanical parts in the way? The answer he laid out in that 1888 paper was just so elegant. It was a concept that was so clever it felt like magic. He called it the rotating magnetic field, or as he put it more poetically, a magnetic whirl. So, here's the brilliant recipe. You start with two separate AC circuits, but the key is you have to stagger them so their waves are out of sync. When one is at full power, the other is at zero. Then you feed each of these circuits into its own set of electromagnets, which are arranged in a circle. So, as that first current hits its peak, its coils fire up, creating a magnetic field that points straight up. Pretty simple, right? It's just a normal electromagnet. But here's where it gets amazing. As that first current starts to fade out, the second out-of-sync current starts to rise. Its coils turn on, and the magnetic field, it rotates. Now it's pointing to the right, a perfect handoff between the two. And this seamless dance just continues, down, then left, then back up again, as the two AC waves rise and fall. What you end up with is a magnetic field that is smoothly and continuously spinning in a perfect circle. Tesla had created his magnetic whirl. And this is the core of the breakthrough. There are no moving parts making this happen. No brushes, no sparks, no pieces grinding together. It's a totally invisible vortex of pure force, all generated by the beautiful physics of alternating currents. Okay, so that's the principle, and it's incredible, an invisible, spinning force field. But that's one thing. How do you actually turn it into a machine that can do some real work? How did Tesla build a motor out of this? Well, the solution was almost shockingly simple. You just take a piece of magnetic metal, a cylinder, a disc, whatever, and you place it right in the middle of that spinning field. The field then just grabs it and drags it along. The magnetic whirl makes the rotor spin. That's it. That is the motor. You know, what's truly remarkable is how versatile this one idea turned out to be. Just by changing the design of that metal rotor, Tesla could create two totally different kinds of motors. He made a synchronous motor that locks on to the field's speed perfectly, which is great for things like clocks. And he made a torque motor that has incredible power from a dead stop, exactly what you need for things like trains and heavy machinery. Now, all of this sounds fantastic on paper, but you gotta ask, was it real? Did it actually work? Well, to prove this wasn't just some neat trick, Tesla had his prototypes tested by a very respected academic, Professor W.A. Anthony from Cornell University, to get an independent validation. And the results were a huge deal. One of his very first prototypes clocked in at over 60% efficiency. Now, for a brand new type of machine that had never existed before, that number was absolutely astonishing. It proved this thing was commercially viable. Professor Anthony confirmed it all in his official report. He said the motor had very considerable rotary effort. In other words, a ton of torque. And he was blown away by how fast it could be reversed. So fast, he said, you almost couldn't even see the change happen. It was official. Tesla's machine worked, and it worked well. And that validation from the professor wasn't just some academic victory. It basically lit the fuse on a full-blown industrial revolution that was about to change everything. And things moved so quickly. In 1888, this whole thing was just an idea in a paper. Just 5 years later, the entire Chicago World's Fair was lit up by the AC system. And only 3 years after that, they used Tesla's system to tame the power of Niagara Falls, creating the first modern power plant and proving once and for all that AC was the future. And the legacy of that motor? Well, it's literally all around us. It became the quiet, reliable workhorse inside factories, refrigerators, power tools, fans, everything. It is the engine that built the 20th century, and it's still the backbone of the power grid we all rely on today. So, I think the crucial takeaway is this. Tesla's genius wasn't just in inventing a new gadget. It was in seeing the problem differently. He identified that one inefficient, unnecessary part, the commutator, and he simply designed it out of existence. By removing that mechanical middleman, he made the whole system simpler, more reliable, and so much more powerful. And that leaves us with a final thought, right? Tesla looked at the way things were done and saw this clumsy step that everyone else just took for granted. So it makes you wonder, what are the commutators of our time? What are the complex, inefficient systems we just accept today that are waiting for someone to find a more elegant, simple solution?